Ever wondered how HVAC chillers are classified? Let's break down the fundamentals according to ASHRAE standards. First, we classify chillers by their refrigeration cycle. Vapor compression versus vapor absorption. Vapor compression uses electric motors to circulate refrigerant. Absorption utilizes heat sources like steam or hot water. Second, by heat rejection method, chillers are either air-cooled using fans or water-cooled using cooling towers. Third, vapor compression chillers are defined by their compressor technology. Reciprocating uses orbiting spirals, both ideal for small to medium cooling capacities. Screw chillers use helical rotors, while dynamic centrifugal chillers both ideas handle massive commercial loads. This cycle has four main parts: the compressor, condenser, expansion valve, and evaporator. At point 1, the refrigerant leaves the evaporator as a low-pressure, low-temperature vapor, usually slightly superheated, to protect the compressor. The compressor raises the refrigerant pressure and temperature, so from point 1 to point 2, we get a highly temperature to protect the compressor. In the condenser, heat is rejected to the surrounding air, so from point 1 to point cools down and changes into a high-pressure liquid, the compressor. At point 3, the refrigerant is best described as a high-pressure liquid, typically saturated or slightly subcooled, depending on system design. In the evaporator, the refrigerant absorbs heat from the space or chilled water loop. That is the real cooling effect of the system. Next, the expansion valve suddenly drops the refrigerant pressure. This creates a low-temperature liquid-vapor mixture at point 4. After absorbing heat, the refrigerant becomes vapor again and returns to the compressor. That completes one full refrigeration cycle. These diagrams help us visualize the process. Compression raises pressure and energy, condensation rejects heat, expansion drops pressure, and evaporation absorbs heat. So remember the cycle in 4 words: compress, reject heat, expand, and absorb heat. That's the foundation of refrigeration and air conditioning. I hope this made the vapor compression cycle simple and clear. In the next lesson, we can go deeper into each component in detail. In this short lesson, we'll understand what an air-cooled chiller is, how it works, and when we use it. An air-cooled chiller is a refrigeration machine that removes heat from chilled water and rejects that heat directly to the outdoor air. Inside the evaporator, the chiller cools the water. Then the pump sends this chilled water to the building load, such as AHUs or FCUs, to absorb indoor heat. The refrigerant leaves the evaporator as a low-pressure vapor, enters the compressor, and becomes a high-pressure hot vapor. Then it moves to the condenser. In the condenser, outdoor air flows across the coil. The condenser fans reject heat to the atmosphere, and the refrigerant changes into a high-pressure liquid. Next, the refrigerant passes through the expansion device, where its pressure drops. It becomes cold again and returns to the evaporator to repeat the cycle. The main advantages are lower initial cost, outdoor installation that saves indoor space, and no need for a cooling tower or condenser water system. Its disadvantages are lower efficiency than water-cooled chillers, especially in hot weather, and performance that depends on the outdoor ambient temperature. Air-cooled chillers are commonly used when simplicity, lower first cost, and easier installation are more important than achieving the highest possible efficiency. Now, we'll quickly understand how a water-cooled chiller works, why it is highly efficient, and where it is commonly used in large buildings. This system works through 3 connected loops: the refrigerant loop inside the chiller, the chilled water loop serving the building load, and the condenser water loop connected to the cooling tower. On the chilled water side, warmer return water comes back from the building and enters the evaporator. The refrigerant absorbs heat from this water, and the pump sends the cooled water back to the building. Inside the chiller, the compressor raises the refrigerant pressure and temperature. Then the refrigerant enters the condenser, where it to the condenser water instead of being rejected directly to ambient air. The condenser water carries this heat to the cooling tower. At the cooling tower, the heat is rejected to the outdoor atmosphere, and the cooled condenser water returns back to the chiller condenser. Water-cooled chillers offer high efficiency. They have large capacity. But remember, more equipment is required.